Okay, so looking at this unit circle right here, if I told you that you were responsible for all that information on there, it would be kind of overwhelming, right? Which everything is at first when you take it all together. So let's back up. We'll break it down. And we'll come back up here to the top of page 4, okay? We've talked about this, but here's the official definition. A quadrantal angle. Most of the angles we've seen so far, theta, they terminate in one of the 4 quadrants. But every once in a while, you'll have an angle that terminates on the x or y axis. That's what a quadrantal angle is. Quadrantal angle is an angle that terminates on either the x or the y axis. So like 0, 90 degrees, 270, 180, 360. When you have an angle that terminates on the x or y axis, there is no reference angle and there's no reference triangle. You're essentially collapsing it down vertically or horizontally to nothing. All right, but you could still have trig ratios. I'll show you what I mean. On example 7, for a circle of radius 1, where it's centered at the origin, find the value of the 6 trig functions for each of the following. Okay, so here we go. What would my angle of 0 look like? Well, it would look like this. Right? I haven't rotated at all, so there's 0 degrees. If I'm looking at a circle that has a radius of 1 unit, then what would the ordered pair be out there? If I start at the origin and I go right 1 unit, it would be 1, 0, right? Which, remember, that is the x and the y. So what we've done here is we've collapsed our triangle down to nothing vertically. There's no height to it. But if I know the x value is 1 and the y value is 0 and the radius is 1, I can still talk about the 6 trig ratios, right? So let's do that for 0. What would sine of 0 be? 0 degrees. Well, sine is y over r. So that's what over what? 0 over 1, which is what? What's 0 divided by any number except 0? 0. If you remember, sine measures the relative height of the triangle. It's y over r. And since our triangles collapse down to nothing on the x-axis, it makes sense that the sine, which measures the height, is 0. Sine, y, height. You hear how they all have the same sound? Sine, y, height, height, sine, y, height, sine, y, height. All the same. Same annoying I sound. Helps you remember it. All right, what's cosine of theta, or cosine of 0 degrees? Well, that's x over r. If x is 1 and r is 1, that's 1 over 1, which is 1. What would tangent be? Tangent of 0 degrees, that's y over x. That's 0 divided by 1, which is 0. And now if we look at the reciprocals here, we've got the reciprocal of sine is cosecant. What's cosecant of 0? Well, that's r over y. That's going to be 1 over 0. What's 1 divided by 0? Doesn't work, right? Can't divide by 0. So we're going to say DNE for does not exist. Doesn't exist. What about the secant of 0? Secant is r over x. That's 1 over 1, which is 1. And what is the cotangent of 0 degrees? Well, that's x over y. That's 1 over 0. What's 1 over 0? DNE. Bless you. So at 0 degrees, when we've collapsed the triangle down to nothing, there's 2 trig ratios that don't exist, right? Because y is 0, the 2 that have y in the denominator, they don't exist. All right, so if I started rotating that radius, and I'm going to kind of animate it for you here. If I rotated the radius, my angle's getting bigger. What's happening to the triangles now? The triangles are getting, they're going from, yeah.
How can the r be equal to x if r is the hypotenuse of the triangle?
Well, look what we're doing here. R is the hypotenuse, yes. If you kind of come from 90 degrees down to 0, follow these triangles that I just drew, right? They're going from tall to shorter, to shorter, to shorter, to shorter. When I hit 0, what's happened to the triangle? It's flat. I've collapsed it down to nothing. And so the hypotenuse is now laying flat on the x-axis, which happens to be the same thing as x. Those are the extreme cases. When you're on the x or y axis, you're at the extreme cases of your triangle. You've collapsed it down horizontally if you're on the y-axis, or as we just did vertically, you've collapsed it if you're on the x-axis. So either the height is going to be 0, which is the y value if you're on the x-axis, or now as I rotate up to 90 degrees, notice what's happening. My height went from 0, collapsed down to nothing, to a little taller, a little taller, a little taller, a little taller, so that when I get to 90 degrees, way up there at the top, what have I done to my triangle now? I've collapsed it down horizontally to nothing, right? And what would be the ordered pair up there if the radius was 1? Well, you start at the origin, you go up 1, that's 0, 1 now, right? If the radius is 1, as I rotate up, I'm at the point 0, 1. Well, since that's an x value, and 1 is a y value, and the radius is still 1, I can list all my trig ratios. So here we go for 90. Sine of 90 degrees is what? Well, it's y over r. Y is 1, r is 1, sine of 90 degrees is 1. That measures the height of the triangle, remember? So this would be the maximum height of a triangle when it doesn't exist. Cosine of 90 degrees, that's x over r. So while sine measures the height and is the y value over r, cosine measures the width. That's x over r. When you've collapsed your triangle down to the y-axis, the width of the x value is 0. So cosine of 90 being x over r is 0 over 1, which is 0. Tangent of 90 degrees, that's y over x, that is 1 over 0. Does that work? Doesn't work. So the tangent ratio doesn't exist. The cotangent of 90 degrees, that's x over y, that's 0 over 1, that is 0. Secant, working down here, secant of 90 degrees, that's r over x, that's 1 over 0, that's also d and e. And when we finish up here with cosecant of 90 degrees, that's r over y, that's 1 over 1, that's 1. So almost identical to when we've collapsed it on the x-axis, but now we've collapsed the width down to nothing, so now the cosine is 0. But notice still 2 of the trig functions are undefined, namely when we divide by 0, which are the 2 trig functions that have x in the denominator. Now, if we keep rolling around to 180, what's the ordered pair over here at 180? These triangles now are going to get smaller and smaller and smaller. So by the time, boom, I hit 180, I've collapsed the triangle down to nothing again. The ordered pair is negative 1, 0. All right, so sine is going to be y over r. That's 0 over 1, that's 0. Cosine is x over r. That's negative 1 over 1, which is negative 1. I'm not going to list them out, but you could go ahead and keep doing that. And if I then keep rotating all the way down to 270, now your triangles are getting very narrow again. And boom, down here at 270, I've collapsed the width down to nothing. The ordered pair there is 0, negative 1. So x is 0, y is negative 1. And you can list all the trig functions there if you want. And then coming around full circle to 360, the sine of 360 should be the same as sine of 0. The cosine of 360 should be the same as the cosine of 0. All right? So that's essentially what we're doing. As we go around the circle, our triangles are going to go from the x-axis, where they have a 0 height, to a 0 width. All right? So we really like our angles to land somewhere in the 4 quadrants, because then I actually have a triangle. And without it, I don't have a triangle. All right, so what we just saw right there is called the unit circle. Here's what makes it a unit circle. It's a circle that, first of all, has a radius of 1 unit. Whether it's 1 feet, 1 mile, 1 yard, and that's what I did over here. I let the radius equal 1 unit, and I went out to the point 1, 0. And the other thing that makes it a unit circle is it's centered at the origin. Centered at the origin. Now what we're going to do right now is get our angles ready for tomorrow when we'll actually develop the unit circle full-fledged. Remember in geometry, you had your 2 special right triangles. This is example 8. your 30, 60, 90, and your 45, 45, 90, right? They were special because, as the sexagesimal number system, they have their nice multiples or integer values that go into 360 very, very easily. So let's kind of review that. Your 30, 60, 90 looks something like this. There was 90, here was 30 degrees, there was 60 degrees, right? So the way that you can label these, and hopefully you still have them memorized, opposite the smallest angle, 30 degrees, you just give a unit length of 1. And then everything is determined after that by that smallest side of 1. The next largest side is opposite the next largest angle, 60, and that was the square root of 3. And then the side opposite the largest angle, 90, that was 2. So your 30, 60, 90 was your 1 square root of 3, 2 right triangle. And if you know this, then you can dilate it. You can make them bigger by multiplying all 3 sides by a number, or make them smaller by dividing all 3 sides by a number. The other one was your 45, 45, 90. That was your isosceles right triangle. And, of course, opposite the smallest angle of 45, you give a unit length of 1. And then by the Pythagorean theorem, you get the hypotenuse of the square root of 2. So that's your 1, 1 square root of 2. Yeah?
Will the unit circle do on my test?
Yes. We're going to finish developing it tomorrow. Right now we're just laying the groundwork. So here's what I want to do. Because your 30, 60, and 45 degree angles are the most common and very useful, what we're going to do is we are going to scale both of these triangles so that their hypotenuse, which remember ends up being the radius on the unit circle, we're going to scale them so that their hypotenuse has a length of 1. And let's see how we could do that very quickly. For instance, if I want to make the hypotenuse a 1, all I got to do is multiply both sides by a half. And these triangles are proportional. So that gets me the following triangle, 30 degrees, 60 degrees. I end up with 1 as the hypotenuse, 1/2 as my shortest side, and square root of 3/2 for my next largest size. So what we did there is we made the hypotenuse 1 unit long. And the last thing we'll do today very quickly is we'll do the same thing for this one. For your 45, 45, 90, if I want to make the hypotenuse 1, I'm going to divide by the square root of 2 all the way around. And now the hypotenuse, the square root of 2 over square root of 2 is 1. If I rationalize the 2 other sides, I get the square root of 2 over 2, and square root of 2 over 2. And now the hypotenuse of that triangle is 1. So what we'll do tomorrow now is we're going to draw a unit circle, a circle with the radius of 1, and we're going to rotate all the way around from 0 to 360, and we're going to stop at every angle that's a multiple of 30, every angle that's a multiple of 60, and every angle that's a multiple of 45, and we're going to use these numbers to help us get the ordered pair, and therefore to help us get the 6 trig functions. All right? So that's why we make the hypotenuse a 1, so it fits on the unit circle. So we'll stop right there. We covered, kind of set the groundwork. If you still don't have your trig functions memorized in terms of x, y, and r, make sure you do that as soon as possible. And if you don't mind clearing out your calculators for the next class so they don't have any of the work from the quiz on there. So that's it.